Hi everyone, welcome back. I am looking forward to this series. I designed it so that people all over the world can understand or can start understanding scientific literature and how to use that to your advantage so you can actually shut out the fakers and think for yourself. First things first though, I just want to make sure that you understand that to get to the level that we PhDs have takes from 3.5 years to 7 or 8 years, depending on where you are in the world. And obviously I won't be able to tell you all the intricacies and all the ins and outs in this series, but at the end of the series you're going to be able to verify everything and anything that anyone sends you in a group chat or in a normal social environment. Let's start by understanding the pyramid of evidence. As you can see here, the quality of evidence increases towards the top of the pyramid. At the very base, you're going to find in vitro, which is cellular research, and animal research. This is where research starts and where most of the work is done in labs around the world, including my lab. Then going a little bit up, you have ideas and editorials. So these are expert opinions or experts writing about their expertise and experience in the field. Then you have case reports, which is usually just an individual case being reported by a physician or a clinician. Then we have the case series, which then you start seeing more and more of the clinical evidence of a particular issue. After you see compelling evidence from these case reports and the case series, we start doing a case control study, which is an observational study used to look at factors associated with diseases or treatments. The case control study starts with a group of cases, which are the individuals who have the outcome of interest or the disease, right? And then the researcher tries to construct a second group of individuals called the controls. The control individuals are similar to the case individuals, for instance, age and gender, overall health status, but they do not have the disease. Then the researcher starts looking at historical factors to identify if some type of exposure to something is more commonly found in the cases that have the disease compared to the controls. And so that's how you can understand how, for instance, asbestos had something to do with some health issues that people have when they are exposed to it. It's because they saw that difference between control people that were not exposed to asbestos compared to the asbestos population. Going a bit further up, we have the cohort studies, which are also observational studies. That means that they're non-experimental. And in a cohort study, the participants do not have the outcome of interest or the disease to begin with, but they are selected based on the fact that they might have exposure to the outcome that's being tested. So for instance, psoriasis, depression, anxiety, we can always do cohort studies for these sorts of diseases. Then we can start understanding whether a particular exposure to something will cause the disease. So for example, does exposure to stress causes psoriasis? Then, and this is the most important factor here, they are followed over time to evaluate the occurrence of the disease. Some studies might take months, years, decades, or even could be generational, spanning dozens of years. And obviously, the longer the study is performed for, the more data is accumulated, and so it becomes more reliable. Then we have what we call the gold standard in intervention-based studies, the randomized, double-blind, placebo-controlled studies. And these ones I'm gonna explain on my next video along with the systematic review because they are so incredible that they need their own video. Okay, thank you for watching. I'll catch you later. Bye bye.